Good morning, everyone. Thank you for joining us. This morning for our webinar, we're going to talk about creating IAQ baselines for healthier indoor spaces. This morning, we have joining us our presenters, Mike Hadt and Steve Heckler. Mike is on your right up there on the screen on their talk show set. He is the account manager Midwest from RLE Technologies. He graduated from Indiana University's Kelley School of Business. He has more than 12 years of industry experience connecting technology to solve problems in mission-critical and building environments. He has an extensive knowledge of building controls, product applications, and integration to control strategies. And we are super excited to have him here this morning because today's topic is something Mike is super passionate about. He gets to introduce a new product to RLE that he has been anxiously waiting to introduce, and he will do a great job with this presentation. And joining him is Steve Heckler, the GM and Great Lakes Territory Leader for Jackson Control. He's a current student of the IAQ crash course that looks like it started about March of last year. Continuing to the present, I wonder what happened in March of last year to make IAQ the top of the food chain here for his concerns. He has over 15 years of sales and operation experience in building teams to develop and deploy automation and control solutions. His primary focus is on creating custom BAS solutions to specific issues via the Niagara framework. Today's webinar, you're all muted. We will have plenty of time for Q&A at the end of the presentation. Please enter your questions in the chat and I'll moderate them at the end. Anything you enter in the chat is visible to everyone. So if you would rather send a question privately, you can use the drop down and send it right to RLE if you don't want everyone to see your question. Totally understandable. We also have a giveaway at the end of our presentation today. We have an RLE OtterBox mug that we're going to draw for at the very end. So we'll do that and we will notify you who the winner is, and then we'll email that winner for your mailing address at the very end of the presentation. So now with that, I'll hand it over to Mike and Steve.
Right. All right. Welcome, everybody. Thanks for participating today. Steve and I are excited to spend some time with you just talking about indoor air quality baselines. Obviously, it's a huge topic right now, and there's a lot of focus on it. Today, what we'll cover is kind of how we're measuring that. We've got a new product announcement that we're going to showcase with the new Wing wireless CO2 sensor. With that, we'll get into, obviously the measuring of all of that data, but how do we do the next phase of, once you understand how good or bad your air quality is, what do you do about it? And that's where Steve and the Jackson teams really shined in delivering ionization and other products into the marketplace. So we'll have him touch on that a little bit and how we're visualizing that as well. So moving on to getting started, I guess probably the best thing to do, I think I've seen about everybody do, is really define what is indoor air quality, right? What is IAQ? It's the buzzword, right? So according to the Environmental Protection Agency, it's the quality of the air in and around the building structure, especially as it relates to the health and comfort of the building occupants. You don't see it, but it's all around us. And back one real fast. There's short-term effects and long-term effects. The easy ones to typically identify that you're in a kind of a poor indoor air quality is you may start to experience headaches or dizziness, or I don't know if you've been in a room and you start to have eye irritations or nose or throat or anything like that, but I know I've been in some buildings that have caused that. And then there's some other facilities that, with long-term effects, may not be your typical building structure, but it certainly could be an industrial plant or another type of facility like that. Long-term effects could easily be respiratory diseases or even cancer. So, the focus and strategy around eliminating these indoor air pollutants is critical now. It should have been critical for the last 100 years, right, Steve? But
yeah, really.
And some of the strategies that have existed was energy saving, not always the cleaning of the air and delivering the best possible fresh air for the space. So we're excited that we're able to kind of participate with that now. So
yeah, I think I would add the other things that really more widely affect people when it comes to indoor air quality aren't going to be on this list. It's not that you're going to go in your office every day and have a headache or you're going to be dizzy. or you're going to end up with cancer. You know, there are things with indoor air quality that affect you long term. You may be going into work and not just not being the best you can be. You might be having strange feelings in the building that, you know, maybe you're thinking you don't like your job. The building, the quality of the air you're breathing and the quality of the space you are in can affect you long term over time. And it may not be as obvious as something like a headache. So taking care of that, there's tremendous long term effects that may not be so easily apparent.
So where does it come from? Some of the obvious ones are cleaning products. Now, think about that, right? We're in all these buildings, and we're so excited to want to. Well, we're probably not that excited to do it, but to clean everything. But all of the cleaning products are emitting odors and stuff into the air that we're breathing. So we want to make sure to try to minimize that and knock those and minimize that as best we can. Smoking, obviously, in any indoor space is not going to be good. And then the bottom left picture is supposed to represent building materials, paints, cleaners, things like that for building spaces. And, you know, on the top right, you know, we're talking about the indoor air and the control strategies is bringing in fresh air from the outside. But what if you got poor outdoor air quality? You don't want to bring that into the space. So measuring what's coming into the building as well is certainly a pretty solid strategy. And then obviously making sure you have filtration, proper filtration is another way to accomplish that, and making sure that you have cleaner air in your space.
And we were going to add another picture to this slide, which was just going to be a computer monitor, because it may not seem obvious, but our electrical devices and our computers and our servers, all of those are putting off things also that can negatively affect you. Also, just getting new furniture. If you get new furniture in your office or in your house, you know, we like new car smell for some reason. I know we all do, but it's actually bad. Those are VOCs. We really shouldn't be breathing it, but you know, anything like that will have a negative impact to IAQ.
So, you know, inadequate ventilation, building envelope. It's probably more critical than most people realize. But if you have gaps in your windows, your doors, your ventilation system, holes in the roof, or you know, different things like that, your building envelope is, you know, sealing that is something that's pretty important. And then air exchanges. Maybe your control strategy isn't allowing enough air changes to replace the inside air with outside air. But again, I have the little star there because you don't want to bring bad air into the space. If the air inside of the space is already satisfactory, then you don't want to bring polluted air in. You know, and other reasons why would be mechanical ventilation devices may have failed, or even the air handling system doesn't work properly. Or, you know, what we're here ultimately to share and really expand upon is maybe you don't have sensors to even measure this. Maybe it's not even something that you're not even caring about or visually see to make it a priority. So, you know, those are some of the things that we're going to talk about and continue to expand upon to, you know, just share our thoughts on that. So as Steve and I were sitting the other day with Jenny and Ashley, we're kind of sitting, all right, well, how do we keep good air in and bad air out? We've already touched on a couple of these, but, you know, you have to measure it. That's first and foremost, you have to measure it. We have to ensure that the air is being circulated. You're getting fresh air in. You know, your mechanical capabilities and your filters are all proper. But then we listed out the ionization, UV lights, and filtration as I guess we would call it an order of priority, right? Just because of the way they all work individually and in tandem with each other, quite honestly. So I know Steve's going to touch on that a little bit more, but the ionization is going to kill the air all around us, all the bad bacteria. The UV lights are going to, you know, kind of help clean and bring safe air back into the space, and obviously the filtration is going to kind of knock some of that bad stuff out as well. So
yeah, it's important to look at it that way. You'll see, I'm sure, even this week, we have all received emails from different companies that are saying, do this, don't do that, do UV, don't do ionization. And then you'll have ionization guys say, do ionization, don't do UV. That's ridiculous. You must do, if you want to get the best you can be, you're going to find the right time to do all of them the right way, because they all serve a purpose. Ionization is air, UV helps with air a little, and also surfaces and duct, and of course you need filtration. So it's really a mix. If you want to get to the penultimate healthy building, you don't ignore any one of these or say any one of them is worth less than the other, because they are different and they do different jobs for you.
Right. And I was reading a study the other day, and I think the main theme was there is no silver bullet to kill everything. I mean, based on budget, based on capabilities, based on the technology that's available in any particular space, some form of all of them need to be in place to really minimize the bad pollutants in the air as best as you can. So, as Steve said, I mean, got to kind of have them all to really deliver the best possible building. So some of the things that we were looking at is, all right, well, with the RLE technology, what are we doing, and how can we help to create some visualization and data, right? At the end of the day, we all make decisions based on data. So, what are some of the tools we currently have today? We have the temp humidity monitoring. There's a little smaller guy, but the one that's been pretty popular currently is the Wi-Fi temp humidity. This guy here is another temp humidity, but has also been introduced with CO2. So now we're able to measure temp humidity and CO2 in the same wireless device, 900 megahertz.
Do you want me to stop sharing so you can hold up the camera?
Oh, that's all right.
Look at the camera.
I think we got to
do it later.
One.
Okay.
And then the differential air pressure. Differential air pressure is making sure that you're either got positive or negative pressure, and you're either pulling good air in or pushing bad air out. And obviously, if you're not measuring that, you don't know. Another use case I've seen for the differential air pressure sensor is also inside of the filters, where you can measure filter status almost. So you know how clogged up the filter's getting and how much air is actually flowing through. So great use case application. And then on the right, I've talked a lot about this over the last couple of years, and I just keep telling everybody you can do it, you can't do it, and some people take advantage of it, some don't. But you can take our analog transmitter and hook it up with a 0 to 5 volt, 0 to 10 volt, or a 4 to 20 milliamp output of a sensor, and transmit particulate matters, or VOCs, or even in a duct, or even carbon monoxide. There's a variety of existing sensors out in the marketplace that you can do that with. So, we're excited to continue to tell you that you can do it. And ultimately we encourage you to look at these facilities and try to figure out, what's the baseline, where's the starting point, where's the end goal. I was talking with a colleague of mine last week, and he asked me a great question. He said, well, you should start a conversation with, well, how do you define a healthy building? Like, oh, that's a great conversation starter, because I think everybody's got a general perspective and an idea about what to accomplish, but it's how do you accomplish it, and what budget's available to do that? How do we create a migration path to get you from point A to point Z in the most effective manner? So, I like talking about it and sharing it. Since I have it sitting here, since I'm talking about the analog, I know this isn't on topic, but I just did it yesterday and it worked like a dream. I have an analog transmitter in this box here, and I have a current sensor, self-powered CT, and there was a pump that was a trouble for my customer. And what we ended up doing was snapping this onto one of the phases, and literally in no time, I'm able to start visualizing and seeing in real time amp draw on that particular phase. So, they were having issues with pump burnouts and things like that. So again, you can do it. I just want to make sure I keep saying you can do it. If you have questions, let us know. We'd be happy to work with you on showcasing that as well. So enough about the analog, but keep in mind, you can do it. So here we go. I'll walk up to the camera so you can see this a little better. The launch, new product, right? New product alert. CO2. Now you can see this case might look a little different than the black one you're normally used to seeing. We're working on finalizing this for commercial use as well. But actually, in your chat, go ahead and let us know how many of these white cases you think you deploy in a commercial building. So we can go ahead and start pre-ordering some of those for you as well. But it's a new product announcement. It's working off of our 900 megahertz. I don't know, did I get close enough here?
Yeah, take it all the way up.
900 megahertz. I know I already got the case off of it over there, but pretty simple to set up and deploy. You know, works just like our other 900 megahertz sensors, where it auto discovers. You know, there is a little bit of a process involved just because it's CO2. So you can see the little red dial on there. One of the things that our engineering had built into this is compensating for the sea level and different elevations that you may be at. So that's what that is for. And then, you know, the other neat thing that I think is pretty cool about this sensor is it's self-calibrating. So every 2 weeks in typical occupied spaces where it would ideally zero out at like midnight or something like that, it'll auto-calibrate itself. And then the other cool thing that I think everybody would appreciate that's going to put this guy into any commercial space is that the sensor module should last up to 15 years. So with the self-calibration and the module lasting up to 15 years, it's not a maintenance burden for some of those spaces. Range is, I mean, you can read it in 0 to 2,000 parts per million. Accuracy is 30 parts per million. The selectable CO2 measurement, it's defaulted to 2 minutes. So obviously, if you want to send that signal maybe every minute or a higher level, you're going to have some impact on battery performance as well. So keep that in mind. But you know, when you do deploy this guy, you're not just getting CO2, but you're also getting temperature and humidity. So, you know, being able to deploy a guy like this into any facility or space and grab all of that data all in one shot, I think is one, a big time saver. I think we talked about in one of our last webinars, the challenge with labor, the cost of labor, obviously the cost of running wire, and now being able to integrate this data point into an integration strategy so that your building automation system, assuming it has the mechanical capabilities to drive that performance, now has the data to do that and the intelligence to.
And you can move it around or make it temporary. Like,
right.
You know, it's not a permanent fixture. So
right.
that I think we like a lot for commissioning purposes.
A mobile, we'll call it easy IAQ, right? Being able to mobilely take a set of products and deliver them into different spaces to grab that baseline measurement is critical now, you know, because not everybody's got 50 grand to deploy a brand new system out into a space just to do it, right? I mean, let's again think about a migration path, how we can you know, start to create more value, but then also create a safer environment for everybody that's there. So
nice.
What do you think about that?
I love it.
So again, we keep talking a little bit about what do you do with the data and why do you have the data. With CO2, what you're really after is demand ventilation. So, you know, different floors and different buildings, different spaces based on occupancy are going to have more CO2 in spaces where more people exist, right? That's what we're breathing off. So, in maybe the first floor, you'd have more fresh air hitting that space versus the third floor because you only got one person there, right? Or the fourth floor. You're going to need more fresh air coming in or filtered air, or, you know, obviously the other strategy to make sure you have good air is ionization, or even as we talked about the UV lens. But we got some pretty neat stuff that we're going to showcase here shortly regarding ionization that ought to blow your mind, right? So anything else to add about that CO2 reset?
Well, yeah, I mean, we've done that for a while with demand control ventilation, but now we're at a point where, because of the obvious, we're looking at more about our indoor air than temperature, humidity, and CO2. So we already know all those sequences for demand control. But should we go into that sequence without first checking the actual quality of the air inside? The obvious answer today, 2021, is no. But in 2019, it was yes. You know, like if there's less people in the building, less CO2, go ahead and shut down the outside air with no check of what the quality of the air actually was. So, you know, like Mike said a little bit earlier, for 100 years, we should have been doing it this way, and we just didn't. So now it's time to do it, you know, and to talk about the impact of good IAQ connected to your IoT through the BAS. So see if we can get a few more acronyms. But this is pretty essential. Good IAQ, fewer sick days, improved focus, increased employee productivity, higher test scores, safer air to breathe. These are all things, that have been tested through, you can Google search and read all about how IAQ, good air, helps people. But we've kind of ignored it inside buildings as we've been building them and retrofitting them. And now we're trying to, why these pictures are here, why you have a waterfall on the outside, we're trying to return the indoor air to as good as the quality of the outdoor air. Unless, of course, you're right next to a factory and then, you don't want to let that air in. But that would be the purpose of an outside, like you have an outside temperature sensor, an outdoor air quality sensor. So then where is the best air today? Should I be letting outside air in? Should I not? And the building can run even a little bit better and healthier.
I'll tell you where some of the best air was when I lived downtown a bunch of years ago. Was right by the Blomer chocolate factory. It always smelled like chocolate. It was great.
Yes.
That's a Mike ad right there.
I wasn't expecting that one. That's good. So ionization takes the lead. Ionization, there's a couple pictures of just the sample install, how it would go into a big built-up air handler. So I want to make sure that we state that ionization is the fastest thing that you can do other than walking around in a building and misting everybody while they're in it. It's something that you do that surrounds people, if you haven't studied it, it surrounds people with negatively charged ion particles. Conversely, why I brought up a computer monitor and servers earlier, monitors, servers, cell phones, those things naturally put off positively charged ion particles, which are a little bad for our psyches. So ionization, you put it in your duct, you're surrounded by the cloud. When you have a positively charged particle, which viruses just so happen to be, bacteria, allergens, ionization will attack that. That does not mean that you put in ionization instead of UV or instead of filters or instead of changing a ventilation sequence. If you have limited budget, you have to do something first. Ionization does a great job. It is the first thing you should do as a total package to taking care of the healthier building. And I mean, we've seen a lot of great success with it here at Jackson Control. I think, Mike, we've got some people who are interested in it. We have found ways to use the analog sensor where we can connect particulate matter sensors to that analog wireless sensor and bring it into front end to BAS so there's a visual. And a lot of the times people are asking, when you emit that ion cloud, similar to the virus, obviously you can't see a virus. You can't see negatively charged ions either. This slide here just gives you an idea of virus size because that's the catalyst that's making us look at IAQ. So this is a human hair, and then it's trying to tell you, a human hair and a virus compared to each other. The easiest analogy I can give you is if you think of your body as being the size of a human hair, then a virus is the size of the tip of your finger. So obviously extremely small. So how do you measure that? And we do have tools and equipment to where ion meters where we can measure the amount of ions in the air. But you can do it with particulate matter sensors because ionization doesn't target coronavirus. It's the things we're talking about doing, to current situation, our pandemic, COVID-19 is the catalyst of why we're looking at it, but it doesn't stop there. It's affecting bacteria, it's affecting smells. If people have allergies, it helps with that. It has been known to reduce radon gas. Obviously, any kind of VOC. So, when the next evolution of whatever bad thing comes into the air, ionization, UV, filtration, ventilation, all of that will still continue to work and protect us. So it's we get a little wrapped up sometimes in COVID-19, but that's not it. Like that's not the only thing that's hitting us that's bad. It's just the most obvious at this time. A little description about what ionization does. It's essentially electrostatic filtration. You've got particles that are positively charged, negative ions attached to them. And once it bonds with them, it causes them to, it actually, I guess we'll use the coronavirus as an example. The RNA of the corona, of the virus, gets affected when the negative particle attaches to it. You have kind of a robbing of hydrogen, which the virus uses for energy, but then it also causes a little reaction to happen to where the virus can no longer mutate. There is a lot of misstated information that ionization kills viruses. Ionization inactivates viruses, it neutralizes them and other particles, and then they die off naturally. If they're not able to mutate, they're not able to make you sick. And that's what's actually going on. So when you see, that ionization is killing something, it's not actually the case. It's just affecting it where it can't do anything. And then they die on their own after, I think, 5 minutes is in the case of the coronavirus. So down here, this little chart, one thing you'll look for when you're talking about UV or ionization, you want to see some kind of efficacy reports with kill and inactivation rates. This is one when we have a building that has between 1,000 and 2,000 ions per cubic centimeter. These are the results you get for these different things. And you can see E. coli, the norovirus, there's MRSA, and then COVID-19, and then what that kill and inactivation rate. So whenever you're looking at a product, whether it's from Jackson Control or somebody else, you want to get an efficacy report. You want to know that it's UL299 listed for zero ozone. Make sure you do your research, because there are still some products out there in the market that aren't so great, and you want to make sure that the company you're talking to knows we're not talking about killing at the point of contact. We're calling about neutralizing and just making the space safer and making those things die off naturally. Where is it installed today? Do you have anything to add, Mike?
No, I think you nailed it, Steve.
Okay. So all of these sites, I think it's important that a few of these have installed it since the pandemic began. But I can tell you, Harvard, the White House, and Google, they all had it installed long before the pandemic. We're talking specifically about ionization, and I believe they have UV. These are, again, old things that we've always had, that we probably should have been doing, that we just weren't. But now, we need to make the world better and safer for everybody, so we don't go through that again. So just a little list. And obviously, we have it here at Jackson. Every Jackson Control office has it installed, and we also made sure all of our employees have it installed in their homes. And I think that was huge.
That's a good point. So there's a program that Jackson has around an employee program for all the businesses that are associated and on this call, so you're the first to hear about it. Working with Jackson, they offer like a group package for all the associates and employees to be able to have it at their house, so that at the end of the day, that is where you're likely going to contract or spread a virus. And then when you get to the building, this is already cleaned and has the ionization. So if you can neutralize it at your house and then get to the office, where again it's another safe space, that's a pretty slick way to do it. So make sure to reach out to Steve and the team here regarding kind of an employee engagement program for your company and your associates.
Yep. It's super easy to install. I mean, it is a low voltage device. When you're putting it in your home, we're talking, 2 wires, grounded common. It's got little magnetic feet. Stick it near your blower, close it all up, and then just go back to whatever you're doing.
Breathing clean air.
It's pretty simple.
You're not going to be having sick days. Maybe that's a bad thing.
I know. We're going to stop sharing the PowerPoint, and we're going to show a little demonstration in a smoke box. I think I can go to this YouTube video. I think I got to copy it. Oh, it's not linked. What did that go to?
That was the Jackson little, how it was set up, the cartoon.
Oh, the cartoon one? Yeah, we can log into that in a minute. That one's okay. But if you look in our screen, I don't know how to look to us, but if you look at the screen that Mike and I are on, you should see that box full of smoke.
You see this box full of smoke right now, right?
And when the LED comes on, there's an ion generator in there. When it turns on, it's going to dissipate that smoke pretty quickly. Go ahead and click the button. And there it goes. So smoke is obviously something visual. You can see it. Virus is not. But anything else that was in that box that you can't see that can be affected by ion generation was just affected. So this is the simple block. One of these little guys is worth 2,400 CFM if you're sizing it for a system. So, you would take whatever size your air handling is in your building, and that's just divide by 2400, and that's how many of those you would need. One obviously does most homes, but pretty easy, pretty simple little widget, pretty simple way to get to good indoor air. It was gone pretty quick.
It's gone.
Yeah.
So that was pretty cool.
No, I don't think so. Unless I want to see it again. Yeah.
Yeah, if you want to go into the chat and you want to see it again, obviously reach out to Steve and team or go into the chat and say, man, I really need to see that again. And
we'll do it again. Yeah. I think we'll show that YouTube video at the end, maybe.
All right. So yeah, I mean, this really, kind of closes out the presentation. We good on time?
Yeah, we're great.
No,
we're good. We're perfect.
You know, the goal today, I think, wasn't really to lecture anybody about indoor air quality. It was really to kind of have a general discussion about kind of what it is and why it's important and what people are doing and how they're measuring it and what are the what are they doing to actually take action against poor indoor air quality. So you know, it's important, and you know, it's all around us everywhere we're at. You may or may not realize it, and you know, it's visualizing the invisible is, you know, ultimately what I think we wanted to kind of try to have a conversation about today. So don't forget, we got the new Wing CO2 available for pre-order right now. We got a bunch of them coming in the next 30 days or so. So I know they're going to start flying off the shelf. So make sure to reach out to your contracting partner or RLE or however you normally buy RLE products, and you know, get yours, get your pre-order in now, and you know, let us know obviously if you know the timeline and how many you think you'd put in a commercial space, and you know, we'll look at you know, giving you an idea about the white case here. So I think that concludes everything. Steve, you got anything else? You got a silver bullet somewhere that you want to drop before this ends?
Well, I think if we stop sharing this screen and you go back to ours, to the view where you can see Mike and I, let me get there so I can see it ourselves. Visualizing things you can't typically see. Where are we? Visualize the invisible. So when it comes to ions, there are particulate matter sensors and things you can install in the building, but we also have ion meters. I'll go grab one real quick, and then when it does come to UV, like there was a question about, do we recommend any standards like with well? We're looking into well buildings right now and how this all fits together, but our standard that we kind of try to live by, if you're doing ionization, you're looking for an ion count of between 1,000 to 2,000 per cubic centimeter. And you verify that either by the meters or by using particulate matter. So if you're using particulate matter sensors, you know, you would calibrate that by, you would read it with your ion meter, say you're reading 1,500 per cubic centimeter, and then you introduce something bad, so you introduce smoke. That count should go down as those ions start to interact with things and then come back up as the air is clean, and you calibrate your particulate matter sensor against that so you get a good dashboard. This is one simple ion counter. You have one of those. I don't know if you can see that. And then there's a separate model that reads, it's a little more accurate than this one, reads a maximum of 3 million ions per cubic centimeter. Also, over here on the shelf, I'm going to go grab it. When it comes to UV light, so we put UV in the ducts, but how do you know the intensity of the UV? Let me grab this real quick. So this is, a lot of people haven't heard of these. I hope my microphone reconnected again. This is a UV sensor. You install it perpendicular to your UV light in the duct. We do have these in a hospital up in Maine. But this is the little sensor probe. This can connect to a BAS. So once you button up that ductwork, place where you can't see, you can now add that to your dashboard, get a reading of whether the UV lights just need to be cleaned. You know, you set them up at 100% of their intensity. You look at them a couple years down the road, maybe they're at 80%, maybe they need about wiped off, or a couple bulbs need changed. Each one of these are lab tested and serialized. Every single part number has its own test performed, comes with its own checkoff sheet. That I think is getting missed a lot. I think a lot of people are installing these things and just crossing their fingers and hoping they work. But you gotta continuously measure.
You got to measure it.
Make
I
sure
think
it's
that's part
working.
of the conversation, right? There's
Right.
different ways to measure different things, and I know from past history as well that one of the things people install things and walk away and say, "Hey, it's good, we're good." So it's pretty slick. I think that there are ways to do it, and we're just trying to again bring them to life and share with you different ways that Jackson and other folks in the country and shoot even the world are doing it. So if you haven't heard of some of these things,
I'm going to look at a couple other the trends. So the first trend was just panic, install stuff, install things, install things, install things. What we were just talking about. Put in the ionization, put in the UV. Is it on? Is it working? I don't know. So that's where the measurement comes in, and you're starting to see healthy building dashboards. I can tell you, if you do have a wing manager, since this is an RLE presentation, and you have used that analog sensor, it is really, really easy to bring things into the wing manager and create a very fast dashboard so you can see what's actually going on. The chat is going crazy right now. But that is your trend, not only to install them, but to set up a healthy building, a healthy dashboard. Similar to how for years we were doing energy dashboards. It's really kind of along that same vein, Find information on the system that can be installed in the home. Well, that is good news. I think we can share with everybody on the call today our cut sheets and our specifications and our install guides. And it's really not that much different than than what we put in large commercial buildings. We just size it down.
Yeah. I mean, did we show this? I mean, I know you showed some pictures.
I don't think we actually held that up. That's the actual block.
This is the actual unit. Let's see.
Yeah.
So
pretty small.
Pretty small. Little graphite tips on there, and it's 2 wires. This is the best part. So I got one of these at my house, and I like to tinker with things. I like to think I know what I'm doing a lot of times, but it's 2 wires that gets installed down into your furnace, and it just works. It just works. So that's the cool part, I think. So it's not a whole lot to do to install, and then from a home perspective, even still, I mean, sometimes you got to come about every time you change your filter, maybe flick them off, flick these little tips a little bit. So there's barely any maintenance involved as well, and even if you don't, it's still not the end of the world.
I can tell you from a company that really prides itself on high building technology, ionization is slightly annoying because it is a widget and it is just something you put in, and it's like, this is way off from what we usually do, but it's it's super effective. Remember, are your sensor solutions designed to be used as a tool for an assessment service or consulting company? That is happening now. So that's a great idea. And I would say there's probably 100 companies starting to have that exact same thought right now. We are actively working on putting together a package with RLE that can do exactly that, where you could go in, set it up, take readings, take it out, see where they are, and then advise on what to do next. But that is a trend that's happening right now, and I would say by the end of the year, you're going to see quite a few offerings.
Yeah, I mean, by the end of the month, I would say there'd be a kind of a good packaged set of goods that Jackson's going to be bringing to the market. So keep your eyes out, keep your ears out. Obviously, we'll be ecstatic to share that with you. Yeah. Again, like I said, you can do it, and creating a mobile way to do it and simplifying the overall installation and just the data gathering. That's the big thing. Simplifying the data gathering, I think, is a lot of times some of the challenge, because I know there's some other handheld devices that you can walk around with, but when you leave the room, what happened in an hour from now, or in the morning, or once you pack the room, you don't know. So while it's a great point as far as the kind of the indoor air quality as a service. I think I coined that on a controls trends presentation a while back. I think it's actually taken legs. So anybody know anything about copyrights? I think I said it first. It's probably not. No,
I don't know.
It's being able to leave something in a space for a week or a month or something, and really get the data to drive the outcome. Because obviously with space utilization changing and patterns in your building changing, Those are all things that we really want to pay attention to and understand how your HVAC system's reacting to those. So, and ultimately, how is the ionization working? And, you know, how well is the UV lights? And, you know, do you need to upgrade your filters and, you know, things like that, or your control strategies?
Let's see. Michael Morrison won the tumbler.
Oh,
good job.
Good job, Michael Morrison.
Andrew Marshall. The home unit go in the supplier return duct. So whether it's the home unit, commercial building, package rooftop unit, you know, built up air handler, whatever, you want it in the supply, and you want it after, ideally, you want it after any filters and away from any coils and after all those coils. You want it to be right with your fan or blower or whatever is pushing your air, and then to go directly into the space, because ionization isn't really a filter. It creates a cloud of ions, and then those need to be delivered to the space quickly and en masse. So you don't want them disrupted by, you don't want them to go through filters. It's not, you know, air, the bad air doesn't have to travel all the way back through the duct and pass over your ion generator. The ion generator is filling the space with a cloud that is active as soon as you breathe, and that's what makes it slightly different. So it's kind of, we say wiping the air clean. That's really kind of what it's doing. And when you think about your UV and your filters, you know, one of the analogies I like to use is a swimming pool analogy, because when you think of the swimming pool, here's your swimming pool, and you have the perfect amount of chlorine, and you have the perfect filtration system, and who knows what else, you have the perfect swimming pool, and then you're standing in your pool and a kid jumps in and pees right next to you. You have all those perfect things, but do you really care about how good that filter is that's way over there? Not at that moment. You want to know what is protecting you right now, or you're jumping out of the pool. And that's a little bit this silly analogy of the difference between ionization is it's here right now. Nothing has to travel back through the duct to be affected. So it's that's silly, but it's one of my favorites. Yeah, it's Mike's favorite.
So as we're sitting here, I mean, ionization is coming down and killing the bacteria that we may be breathing or emitting, or, you know, fortunately we're not coughing or sneezing or anything, right? But everything around us is getting secured. Whereas you just said it doesn't have to go back through you know, a filtration process to then be clean coming back out.
So I think, don't see any other questions, and there is, you'll all receive a follow-up email after the webinar, and you'll have links for all the ionization documentation. And if you have any other direct questions, if you're curious about the UV sensor, you know, if you're putting in UV lights and you want to have a way to add the actual UV sensing to your BAS, by all means, give us a call. We have those here on the shelf. You know.
We had one more question that was submitted to us. It's kind of a two-parter. Can you talk about how long ionization units last and what kind of maintenance they need?
Oh yeah, absolutely. So the unit, we see them, we're saying they last 15 years. This, the first ones of these models that were installed have already been running for 10 years. You know, like anything, you'll have some that last 15, you'll have some that last 50. It just depends. But the maintenance, pardon me. Along with that, the warranty on them, you will see, you know, out there in the market, if you're Googling or buying from other companies, you see a lot of 1-year warranties. Jackson Control has them in 2-year and 5-year warranty, but they all should be lasting about 15 years. It just depends on, you know, the situation they're in. If you're in an extremely dusty environment, or say in a restaurant or somewhere with a swimming pool, you actually double up the amount of ionization. So we say each one of these blocks handles 2,400 CFM. That would be in your typical space, like an office space or a school. But when you get into a restaurant, you know, they have big exhaust fans, they have people coming in and out, it's a little bit different environment. Or something with higher humidity, like if they have a swimming pool, then you actually double that. You say, I'm only going to be half as effective because some of my ions are always going to be lost hitting those other things. So you double it up. And then the maintenance is really simple. So they're in your unit. Essentially, the best rule of thumb is anytime you have your filter changes, your regular maintenance where your filters are being changed, you wipe the brushes off on the ion generators. And for that, we're going to develop a special tool. But essentially, you can hit them lightly with a paper towel or something like a toothbrush, but they do need wiped off because while they're doing their job, the most dense, there's 50 million of these being generated at the ion block.
50 million ions.
50 million per cubic centimeter. Not just 50 million, but 50 million per cubic centimeter being generated at the source. So they you're going to collect dust. I mean, there's bad things there too. So they do need wiped off. But that's it. There's no moving parts in one of these. You can shake them. You can put them in you got a rumbling old package unit. You can still put them in there. They're going to run just fine. You can shake it to death, and it'll keep doing its job. Well, I guess I shouldn't say shake it to death. Yeah. I hope that answered that question.
I think it did, and I think that covers all the questions that were in the chat. If anyone has one that they don't feel like we caught, please pop it in the chat again, and we're happy to address it. We definitely have time still.
And then if you want to do a special focused or have a special presentation and get more specific, you can just contact us, and we can go through as deep as you want. We have enough information to probably talk about it for 7 hours and get really deep into the science and what makes these things go.
Cool.
Absolutely.
You want to switch back?
And I know you're both willing to reach out to any of our attendees at any time, and happy to talk air quality and ionization and monitoring at any time if anybody has further questions.
Go back to the PowerPoint, just a short email to close it out.
Oh, there you go. Go ahead.
So this is me, Mike Hadt. That's Steve. You can always reach RLE at sales or support or orders. We're always available to help. We appreciate everybody's time and attention today. Obviously, we're here to help and share what we know, and obviously willing to learn. If there's something else cool out there, please share it with us. I'd like to figure it out. So have a great rest of the day. Enjoy your day today, and breathe well.
Nice touch. Thank you.
That
was good. Yeah, I like it.
All right. We'll see you. Take care.